Today, what we are going to be learn is the complete guide to RTAS task or threat management. And part two, in this today's class, we are going to be specifically study about task control block. Okay, what does mean by task control block? This is what we are going to be discuss on this today's live session. Okay, and what are the things we are going to be discuss in it is, so what is task and what is actually the TCB is actually going to be doing, and what is the difference between PCB and TCB, and we are going to be completely study about this TCB. Okay, first of all, what is task or threat control block? Okay, so we have been discussing about this task. So in this case, what is mean by TCB is, before we are going to be understood the concept of TCB, we need to be know the concept of PCB. Okay, what is mean by PCB is, in an operating system, when there is a process, we can use PCB. That means, if you just taking one example, okay, if you are having one process, okay, if you are having one big task that is going to be processed, so the complete process we call it as an that is going to be completely maintained by PCB. That means process control block. Okay, and inside this PCB, you can able to see the number of tasks in it. That is called as a task or thread. So your task gonna be called as an either task or thread. Okay, in this case, each and every task, if you just consider this is my task one, this is my task two, and every task is going to be vary. Each and every task, it does having a TCP. That means task or thread control block. Okay, if you totally want to be processed, your complete task is going to be get processed. That is going to be managed by process control block. Each and every task, it has the separate TCP. That means task or thread control block. Okay, what is task or thread control block? Why we need to be use this one? If you ask this question, so that is what I'm going to be completely explain about this lab. Okay, so this task control block is one of the data structure. Okay, it is in the form of data structure used by the operating system. Okay, so your operating system, like your R task, going to be use this TCB. Why it is actually using this TCB means, so here also you have been mentioning that TCB, that is a task control block, is a data structure. So what is data structure? So means it is helps to be identifying your task. Okay, so if you are doing one task, guys, so if you are just having one task, so if you want to be understand about this task, whether this task status, you want to be understand the, you want to be know the state of this task, whether it is currently running or in waiting state kind of thing, you want to be understand, and you want to be know the priority number, you want to be store in the memory, you want to be store in register temporarily where you are going to be storing the data, all has been present in your TCP or thread control block or task control block. In this case, when you are having this data, you can update to your operating system. So your data is going to be updated by TCP to RTAS. Okay, that is the main functionality. Okay, we are going to be see the key concept of this TCB. The TCB is a manifestation of a task or thread in operating system. Every task or thread has runs its own TCB maintained by the OS kernel. Okay, so you just look out the flow, guys. So if you are having any operating system, you might be having any operating system. So inside this kernel, so sorry for this one, so you are just want to be processing your task, right? So you have might be having the multiple number of tasks. Okay, so each one task is going to be, each and every task, it is having the different parameters. Okay, if you just take this one as your task one, okay, so this is my task one. Okay, and this is my task two. Okay, it is going to be varies like that. Up to this, it is going to be like you might be having the thousands of tasks you might be having here. Okay, in this scenario, up to 10 tasks I'm having, for example. In this scenario, for each and every task, if you're just taking the task one, so what are the things it is having? So many things it is having, like priority. All right, so it is having the priority and it just having some unique ID, okay, and it just having a states and ID. So we are going to be discuss about this ID concepts and all. Okay, so now you just understood this concept and all. So each and everything, okay, if you're just taking a task one, it is having this. Same task two also having this same priority and states and all. Each and every task it is having a same kind of things. Okay, in this case, what you mean is it is very very important parameter again I'm telling, because of using this. Okay, the OS can able to update the data. Here also, every task and thread runs its own TCB maintained by the kernel. So your kernel is going to be maintained every TCB block, that means task control block for each and every task. Okay, same thing guys, that priority plus states for this one. So if you are taking this task 3, same priority state, so it is going to be called as a TCB. Okay, so we are going to be study this concept detailedly, and if you are not clear up to it, so I want to be tell you one example. Okay, if you just see this example, you can able to understand this concept. The concept is case one. Okay, we will look out this processor. For example, we'll look out the case for the processor, because I told you that when each task is getting the data, that is called as an TCP. Okay, when the whole task you're going to be running, it is going to be called as a process. Okay, so that time it's just using a TCP. So process control block. Okay, just consider as a process control block. So each task it is using a PCB. The whole task when it is processed, that is going to be controlled by the process control block. Okay. And if you just see this one example, when you're just opening your Chrome. Okay, I'm just simply opening my Chrome tab. For example, I'm just simply opening my Chrome tab. Now, if I'm just opening this Chrome tab, you just consider as a PCB. Okay, just consider as a process control block. So what are the important details it's actually going to be stored is, if you are opening anything, if you are just opening any tab, any applications you have been opened, so each and every applications is just having some unique ID. Okay, what are those processor just having? Here it is having a unique ID. Okay, so it's just having some identification number. Okay, so like 1 2 3 4. So when you're just opening some tab in your specific applications, okay, in your specific applications, it is having some unique number. Okay, it has been opened, and you're going to be update the status. Okay, so you're going to be update the status, whether what is the state it is. Okay, so what is the status it is means, so you're having a task. I'm having this task. Okay, I need to be know this contest, right? So here I'm having the total, process I need to be made it here. Okay. So if I want to be do the total process, I'm just simply opening the tab. Okay. I'm going to be tell this one. I'm just simply opening the Chrome application. It is considered as a PCB. Okay, I'm just opening one tab, so it is considered as a PCB. I need to be update the status, whether it is running, whether it is staying or not. Okay, and then program counter. So what are those are coming? So because when you are opening any application, so another other thing is your program counter, which is coming to be what the next instruction it needs to be run. Okay, need the address of this one. So it need to be update the address. And another parameter is memory concept. Okay, if you are opening any Chromes or anything, so your RAM should be temporarily storing the data in your stack or heap memory. Okay, it is going to be vary. So most temporary data is going to be stored on the stack memory, right? So you need to be update the memory size and all. Okay, you need to be update the memory size and open file information. Like means if you just opening on Chrome applications, whether it does require the network or not. It definitely need the required net internet, right? So through that internet only it is going to be connected. So what PCB means, it's just the complete identity, memory details and status of the Chrome. So it's just the example of this. It is a complete application you are trying to be open. For that application, what is the processing ID number and what is the next instruction I need to be run and what is the memory, like if you want to be run, so all the temporary data is going to be stored on the stack memory. Temporary address you need to be know. So these are the parameters in this PCB concept, PCB block. And if you want to be see the threads inside this one, that means processor is just completely running your application or task. Okay, but the complete task is going to be considered as a processor. I mean process control block, process control block. For each and every task, it is handled by the TCB. Every task is gonna be handled by TCP. In this scenario, how I can able to recognizing this TCP block is same scenario. Inside this Chrome application, you are having the multiple threads in it. For example, same example you just take it, guys. Here you just take an example of Chrome. You just simply open the tab called as Chrome application on your system. Okay, this one is considered as an like PCB. Okay, it is going to be run this complete application. Your Chrome application is going to be completely running. For that, the details of IDE and the status, what is the state and what is the memory, everything is going to be updated inside this Chrome. Okay, simply inside this Chrome, if you just see this one, you might be having the different applications. You are having some buttons. If you are simply opening one website, yeah, I'm just open this tab, guys, Chrome application of Pantech solution. Here I'm just opening this tab. Here I'm having the many icons in it. So projects, products, courses. So if I want to be open up anything, I need to be click it. Okay, here I can able to see some buttons in it. Right. So what are those things? Here it is. So same thing. So Chrome, it is if you want to be run the complete application, that process is going to be handled by this PCP inside this each and every task. Okay, your buttons, your networks. Okay, so your network, if you want to be run applications, if you want to be open up anything, you need the internet. So you need to be run the codes in the backend. Okay, so all those things is going to be considered as in threads. This is one of the example, guys. You need to be understood this concept here. So here this case is when you're going to be pressing the buttons, the links, kind of applications. You have been opening some images in it. So if you're just trying to be open up all those stuff, which is comes under the task, each and everything is considered as a task, and this task is going to be handled by this TCP. Task control block. So each and every, if you are handling that button, it is having specific TCP block. For this one, it is having a specific block. Okay. So why Chrome is not? Because it is having a, this is example, guys. You don't look out this concept as very, this is actual thing. So because this Chrome is the complete process, it is going to be run. Okay, it is going to be run all the parameters which is present inside that. That is a button going to be there, links is present, all the thing is going to be run inside this Chrome. That is going to be considered as an PCB. It is going to be controlled by PCP. Each and every task is specifically handled by. Why it is TCP means if you're just taking a button, so what is the status of button? Okay, and what is the memory size? And what is the ID? Everything is having a specific TCB section. So button details, you can have able to get it on this TCB block. And it is having a specific TCB block, specific TCB block kind of thing. Yeah, kind of instructions only, Mukesh. So here, this is how it is actually going to be works. And for each of these threads, the operating system creates a separate TCP block. Same thing, guys. So if you are having a need to be create, this is one of the tasks, guys. You want to be know the details of this task. You just having a thread ID. What is the ID and what is the status of this one? And a stack pointer, program counter, registers and priority. Okay, so if you are so these are the parameter which is present inside the structure because I already told TCP is a one of the data structure. We are going to be assigned all those stuff like your priority number, your state, your stack address, your temporary storing registers, everything, unique ID. So everything you are going to be mentioned in your TCP block for each and every task. So that is what we are going to be do it on the answer session. Okay, so all those parameter is very, very important thing. Okay, for each and every TCP, it is having a specific individual context like this. Okay, and next we are going to be discuss about the concept called as an why does TCP exist? In operating system which needs to be run the multiple tasks. We know that, right? So operating system can able to do this multiple tasks in it. So that time each and every task is going to be have the details like status here. What are the details I've been told? Like your thread ID, state, stack pointer, program counter, registers and priority. So if you just think it for each and every task does have this things. Okay, so for that, each and every task is going to be, if you are doing the multiple tasks going to be done, each and every task which is having a separate TCP block. If the same time, if you want to be switching the task, one task to another task, it can able to be applicable because it is having a CPU registers. It can able to store your data. Okay, I'm going to be explain that, and you can able to track the status. So what is the status of this task? And manage system resources. So you can able to manage the resources and resume the task. So when you want to be resuming the task again, so you can able to do it. Okay, and then the main difference we are going to be see it again. What is the difference between main distinction of TCP and PCB is your operating every process is represented by a process control block. Okay, so which stores all informations required to manage that process. So that is the thing. So you want to be the final end of the thing. So you want to be process on application. You need to collect all the TCP block, right? You need to be collect all the TCP block and then it is started to forward be process. Okay, that is called as a process control block. So it just all as going to be hand over to the process control block. It is going to be started to do this work because it is having all the stuffs, all the informations which is given by this TCP. Okay, I hope you got clear. So when the process is divided into the multiple thread, each thread which needs own management system, that is called as a thread control block. Okay, so now you got clear up to this point, guys. Okay, so PCB means which is represent the entire process. Okay, but this task represent, it is representing only the single task. Okay, it is representing only the single task. At the time, it can able to do the multiple kind of single task, and it can able to process a wide information because the multiples of TCP can able to process called as a PCB control block. Okay, it is going to be handled by the PCB control. So here the thread is actually going to be process the specific informations only. Okay, and it is having a heavier data structure and it is having a lighter data structure, and one per process and it is having a multiple per process. So this is the difference between these two. And next we are going to be discussing about the thread or task control in operating system. Okay, so what is thread or control system? We are going to be see. We already studied this concept. I just recall it. It is one of the data structure, guys, and it is specifically helps to be helping to the operating system to be storing and maintaining the information. Okay, so to for this difference one. Okay, so the difference is simple, guys. The use is different. So if you want to be process this single task at the time, you just go to this TCB. If you want to be do the multiple bulk of tasks, you just go to this PCB. Okay, he just taking out. Okay, and this time the TCP can hold the informations which is having a unique to the thread executions. And okay, so this is the concept. It again I've been mentioned like, so TCP is one of the data structure, guys, and which is going to be helps to track, schedule, manage the things, and also it is helps to be controlling the thing. Like if you want to be pass, if you want to be resume, it can also be done. Okay, so each and every task, what it actually included is, yes, it is the main parameter of every TCP block has been content. If you are having a thousands of tasks and thousands of tasks which is having a thousands of TCP. So this time each and every TCP does require this ID, state, program counter, and the register, stack pointer, priorities, thread specific data, and finally all here I've been mentioned only one TCP kind of overall TCP going to be app the information and hand over to this final PCB block. Okay, and it will be go for processing the data. Okay, now we are going to be see the specific thing for each and everything purpose. Okay, first of all, what is the purpose of thread ID? Here I've been mentioned, we have been mentioned thread ID. What is the purpose of thread ID is, it is a unique identifier. So if you are studying in school, college or working environment, so everyone having some specific identity number, right? So like register number, roll number, kind of employee ID kind of thing. So that's how your ID. So each and every task, okay, every task, it is having some unique ID. If you are taking this one, it is having 1, 2, 3 kind of ID. It is having a 5, 5, 6, 4, 4, 5, 6 and 7, 8, 9 and 1, 2, 3. So kind of different unique IDs only going to be maintained here, guys. Okay. So you're just think it. So each and every thread and task, it is going to be maintaining the unique identifier. That means unique ID numbers. Okay. And then thread status. State. If you are just taking this button, whether that is one of the tasks, whether this task is running or it's just waiting to be run. Okay, so that application, that status is going to be called as an thread state, whether it is running or ready or waiting or block. So last video we have been clearly discussed about this concept. And the program counter. Okay, so if you are having the multiple tasks, if you want to be do the next task, if you need to be hold the next instruction address. Just keep it on the mind. It's just holding the address, next instruction address, not the next instruction. If you're having the multiple instruction, it's just holding the next instruction address. Okay, and then registers. So what is the purpose of register? These are the registers which is called as an CPU temporary registers. Okay, registers that we call it as, because it is going to be store this temporary data, guys. Okay, like these are the registers. It is called as in both are presented here, guys. The CPU registers are two types. One is a general purpose register, another one is a special registers. So where it actually going to be used is while at the time of context switching. What is the meaning of context switching? So I'm going to be explain this. Okay. So these are the registers. So index register, stack pointer, base register, and instruction registers, program status point. So you want to be store the data into your registers. That time it is going to be helpful. Okay, helpful. Okay, and then thread scheduling information. Okay, so this is what I already told you. Okay, here I told you like first of all ID, what is the state and what is the program counter, what is registers, and now information. If you want to be scheduling one task, First of all, you need to be know the state priority number you want to be allocated the priority, and you need to be know this concept called as and whether it is going to be taking a queue pointer or stack, because you are having the multiple tasks like this. So you are having a multiple task like this. If you want to be go like in this queue pointer or round robin or time sliced one. Queue pointer means once the first task has been completed, you just go for the second task, third task, fourth task. If it is a time quantum based one, it is slicing your time. So each and every task has been allocated with a specific timeline. So first task only going to be taking the 10 millisecond. It is only taking a 10 millisecond kind of time going to be sliced, and you are going to be taking the data of CPU time used. So how much time it has been used for this task. And when the task has been created and time spent for this CPU. So these all has been allocated while the scheduling the information. These are the parameters very, very important. Okay. And then memory information. Okay. Memory management information. So here we mainly use the stack pointer because the memory layout inside this memory layout, the stack is mostly used because your temporary data is going to be stored here. Okay. Here, the memory layout sections, which is having like this. Okay. So you're having a dot data structure, dot BSS section, dot text section, dot RO initialized section, read only sections, kind of many things is there, heap and stack. So most of the data is going to be taking this stack section, because all the temporary data is going to be stored here. So that's what we have been mostly mentioned this stack. Okay. If you are taking any sections like this, guys, every sections with just having some starting and ending address. What do you mean? So if you're taking one sections, for example, stack means, so stack section is there. This, okay. So this is completely present in your RAM or ROM memory, for example. This is how inside the RAM and ROM memory kind of sections will be allocated. If you're uploading your code, depends on your data you have been allocated. So each and every data going to be stored in this different sections. Okay. Your local variables, local kind of data is going to be stored in the stack. If you want to be understood this, if you want to be store the data on the stack, you need to be know the what is the total size of the stack, because then only you can able to store that much amount of data. Then you want to be know the starting address, that means base address. Okay. And you want to be know the what is the overflow of this one. So if it is limiting, if just crossing this one, so it is going to be get overflow. So these are the parameter you need to be know. That is called as a memory management. So you need to be know the complete size of your memory sections and memory. Okay, memories and the thread specific data. Okay, so what kind of data you are going to be using. So if you want to be store the private data for a thread, and whether the signal, so it is going to be, these are just a name, guys. Thread local storage means it's just a name if you want to be storing the private data. And a signal mask means it just want to be whether it is blocked or enabled. And error number, if it is a thread causing any errors, it just error number value is going to be provided. And synchronization communication. Yes, these are the topic we have been discussing this last video, right? So what does mean by mutex and semaphores and conditional variables? So synchronization state. So when the task is happening, so all has been, that means the mutex has been specifically allocated. Okay, that is called as a synchronization. Okay, so all the task has been having some specific mutex because it just lock it. So all the resources can able to only access by this task. Okay. And finally, accounting information. Okay. So this accounting information means user time, and you need to be when the task is running, you just simply acknowledging just getting a time. So what is the starting time? What is the ending time? What is the system time? So that is the accounting information. Okay. And finally, before we are going to be know about the concept called as the functions of TCB. Okay, so again, I've been mentioned the same concept. So this is the function it is actually going to be do. If you're creating one task, okay, you need those parameter and context switching. So what is the meaning of context switching? I'm going to be explaining it right now. So guys, here you are having a multiple task. Okay, so we'll look out this concept right now. So I'm having this multiple task like this. Okay, in this time, task 1, task 2, task 3. Okay, for it has been allocated like this. And if the priority task is coming, first of all, the CPU processor processing the task 1. Okay, accidentally, so the task 2 is interrupt. So it is higher priority one. Okay, it is having a higher priority. Okay, this time higher priority is trying to interrupt. It just stopping. It just halt this current process. It just stopping this current working process. It just switch to this task 2, right? It just switching to this task 2. If it is trying to switching to task 2, already just processing the task 1. Some data has been processed here. So if you're trying to be switched from task 1 to task 2, your data is going to be stored, saved, right? Your data is going to be saved. So in this time, you need to be saving your data. How can you saving your data? For that, we are going to be using your registers, guys. I already told you some special function registers and some general purpose register. You're just using those register to be storing your data. When the time it just switching the task from one to another, all the data is going to be temporarily storing your registers. Task A is running. Scheduler detect task B ready. It is a higher priority. It just blocking the task A and OS saves the task A contest in TCB. Okay. And OS restores the task B contest from TCB and CPU start executing the task B. Okay, so simply you just easily understood this concept. You just consider this is task A and this is task B. So the task A is currently active, running. Okay, but if you just see this one, so it is higher priority task. Task 2 is higher priority, is trying to be interrupt. It just block task 1, block the task 1 and just block to the task 1 and go back, go to this B. So when it is moved to this B, saving the content of A and restore, go to this B and start to execute the function of B. Okay, so this is how it is actually going to be happen and then scheduling the task. So we know that what is meant by scheduling. So when you're going to be assigning the task, it is a two types of scheduling, fixed and dynamic scheduling step. So it is going to be varies. Yesterday we've been discussed. So based on priority, you can able to scheduling the task and synchronization. So synchronization means resources. If you are having a task one, what are the resources it has required? Okay, you can take it from registers. Okay, so mutex it can hold up the hold on this one. Okay, just hold on your all the data on your mutex, which can only helps to be hold on that one. All the data has been stored in your registers. And finally, termination. Termination means once the task has been completed, just clean up your every TCB blocks. Okay, and the resources has been cleaned out and it has been done. And finally, how your memory layout will be looks like this. Yes, this is how it is going to be looks like, guys. So shared by all threads. So when you're going to be run this code, your process memory block. Okay, so if you just see this one, this is called as a thread one. So your temporary data. So you just simply see this. Your temporary data is going to be taking this one. So this is a process memory space and TCP which can taking it. I mean uh, this stack memory. Okay. So why it is actually taking a stack memory? Because these are temporary data. Okay. It is going to be varies, depends on the task you have been mentioned. Okay, so the TCP currently taking the stack sections. Okay, so these are the other resources. These are taking this code segment, this data segment, each heap segment, which is taking the shared by all other threads. Okay, and this is how the memory layouts will looks like. And finally, how this TCP going to be works on this multi-threading, same function, creating, scheduling, blocking, and reception. So if it is a multi-threading, because I already told you multi-threading. So this is called as a multi-threading. When you're having a multiple task which is coming, same thing is going to be happen. At the time, context switching going to be happen. Context switching means higher priority task trying to be interrupt. It is going to be stop the current task and priority to this one. And states. So a states, yes, there is a these are the states. You're creating a task. It is ready for this CPU and running and blocked and waiting termination. So this when we have been clearly discussed about this past video. So if you have missed out this, guys, go and watch those one. What are the states in it? Right. So already running, blocked, and terminations. So these are the states in TCB. It is also look out this one and the practical code. So finally, if you are going to be write one code, okay, for TCP, how it is actually going to be look like. So this is how you're going to be write. First of all, you're going to be create the state. Okay, here using NM, have been created. What are the states it might be taking? So here I've been declared one name thread state. It might be I've been created a new thread or whether it is in ready or running or blocked or terminated state. Okay. After that, I've been created one ID using structure. I've been created the specific ID for my task and I've been created the process ID also because I need to be do the both thing. So when I'm having the multiple tasks going to be processed, multiple thread going to be processed, finally I need to be processed by my process control block. Okay, it is going to be handled by PCB. So that is also having specific unique ID and then pointer, stack pointer, because all the temporary data are going to be stored in the stack pointer and a program counter, which is going to be helpful for get to the next address and registers. All the CPU, temporary, general purpose, special function registers, and all going to be stored using this register, going to be storing your data. And then state. Here you have been you mentioning the multiple state and what exact state of your task. And what is the priority, whether it is higher priority or lower priority, and CPU timing you're going to mention, and stack memory size. So what is the total size and what is the base size? Because from where you actually want to be storing your data and what is the total size of your stack. And finally, next and the previous one, which is going to be helpful for linking your data. So we are going to be link list. It is going to be helpful. And finally, the parent process. Okay, so finally, you're going to be processing your entire thing. Okay, this is how you're going to be. This is the structure. Okay, this is how you're going to be creating the data structure you're going to be creating for the task. Okay, so task ID is parameter ID and stack pointer, program counter, state, priority, CPU timing, memory size, stack size, and what is the next and previous one, and finally the parent, the complete process you're going to be run. Okay, so are you clear up to this point, guys? All the people have been got clear up to this point. If, so I hope you guys you clear up to this point. So thank you for this, man.